Hello dear aspirants, this is Dr. Sourav Sir's classes. Our contact number is 98367930076. Again, I am repeating our contact number which is 98367930076. And our email ID is souravsirclasses@gmail.com. So if you have any mathematical queries, doubts or anything, so please feel free to contact on this number. That means you can call on this number or you can WhatsApp also. Rather, you can drop an email to our email ID which is souravsirclasses@gmail.com. Then you can join our regular batches, one-on-one sessions and our online classes, so that will be beneficial for your preparation of upcoming examinations. Okay, so upcoming examinations like the entrance examinations of ISI, CMI, NBHM, TIFR and PUMDET also. So please feel free to contact if you need any help from us. Okay, so now we are going to solve a mathematical problem which is appeared in the PUMDET in the year of 2024, and the question is telling us that the locus of a point P alpha beta such that the lines y equals to alpha x plus beta are tangents to the hyperbola a square x square minus b square y square equals to a square b square is. There are four options here which are ellipse, circle, parabola and hyperbola. Okay, so what can be done here? So the given line is my y equals to alpha x plus beta. So we have to do that. So what can be done here? What can be done here? So we need to determine the locus of the point P alpha beta such that the line y equals to a alpha x plus beta is a tangent to the hyperbola x square minus dy square b square y square equals to a square b square. Then what will happen? Okay, so then we have to see that the condition of for tangency. Okay, so for a line y equals to alpha x plus beta to be tangent to a hyperbola, we substitute this thing y equals to alpha x plus beta into the hyperbola equation. So we will get a square x square minus b square into alpha x plus beta whole square, that is equals to 0. So we will get a square x square minus b square into alpha square x square plus we will have 2 alpha beta x plus beta square, that is equals to 0. Then we will get this thing. Then we will take the common parts of our coefficients of x square, so we will get this thing. And this is my coefficient of x, and the common term will be, and I think I am missing something. Yeah, that will be a square b square. I wrote 0 here. So no. That will be a square b square. Okay. So if we take that, so for tangency, the quadratic equation in x must have exactly one solution, meaning the discriminant must be 0. Okay, so let us think about this thing is my a quadratic equation. Okay, so and the terms are, and we can write it as ax square plus ax square plus bx plus c equals to 0. So this thing will be a, this thing will be b, and our this thing will be c. Okay, so what will be the discriminant? We know that that will be our delta, which is equals to b square minus 4ca. We know that. So let us use it in our question. So that has to be equals to 0. We know that. Okay. Now for tangency, our b square minus 4ac have to be 0. So what is our b square minus 4ac? So we are substituting the values from the given equation in the upper side, which we, so we will have 4 into c into a. Our c is, okay, let us do the plus thing here. Yeah. So then we will have here a square minus b square beta square equals to 0. Okay, so we can, okay, so we can write 4b square, sorry, rather it will be to the power 4 alpha square beta square, plus we will have 4b square into beta square plus a square into that will be a square minus b square beta square equals to 0. So we can see that 4b square will be common from the both thing, and this side is our 0. So we will get, we can divide by the 4b square here because b square is a positive term and 4 is also. So our, we can divide this both of the sides by our 4b square. So we will get now, where is my cursor? So yeah, so that will be b square alpha square beta square plus we will have beta square, that is more like a b. Yeah, this is beta. So beta square plus a square into that will be a square minus b square beta square is equals to 0. Then we have to expand the last term of this equation. So we will get a square beta square plus we will get a to the power 4 minus we will get b square beta to the power 4 minus a square b square beta square. Okay, so again I have to check that I am doing the correct things or not. Yeah, I have done a big mistake here again. So that will be our alpha square. Will be alpha square. That will be alpha square. That will be alpha square. And I have done another, any other mistake here? Okay, 4b square will be common out, so we will get a square beta square plus alpha a to the power 4 minus we will get, yeah, this thing will be cancelled out. Okay, so minus beta square b square alpha square beta square. So this thing and this thing will be cancelled out. So now we will get, I think we have any, we does not have, okay. So there are no mistakes here. Okay. So our a square can be taken common from here, and that we, and their side is 0. So we can write b square plus a square minus b square alpha square, that is equals to 0. So we can write that our b square plus a square minus b square alpha square minus a square, that is equals to minus a square here. So this thing and this thing will be out. So we have b square alpha square minus beta square, that is equals to a square here. And we can write b square by a square alpha square minus beta square by a square, that is equals to 0. Sorry, 1. Rather we can write alpha square by a by b whole square minus beta square by a square, that is equals to 1. So this thing is the equation of a hyperbola. Okay. So we got hyperbola here. So the correct answer of this question, which is asking us that the locus of the point P alpha beta such that the lines y equals to alpha x plus beta are tangent to the hyperbola a square x square minus b square y square equals to a square b square is our hyperbola. Okay, so again I am telling that if you have any other mathematical queries, doubts or anything, so please feel free to contact, then our team can arrange a doubt clearing session for you. After that you can join our regular batches, one-on-one sessions and our online classes, so that will be beneficial for your preparation of upcoming examinations. Okay, so please feel free to contact if you need any help from us. Okay, thank you guys, hope you understood. Thank you.